And now, a brief discussion about volume with props. Yes, that's right. We're going to talk about volume. That's the next thing we're going to get into as we transition away from scientific notation and into volume. And Pythagorean theorem is going to be tied into that. But first, we're going to talk about volume, which is a word that you should know. We're just going to talk about what it means. What is the difference between volume and area? Why are they two different things? Are they the same thing? So let's talk about that right off the bat. So there's going to be a couple of things we're going to talk about in this video. It's about volume of any prism, and really going to focus on rectangular prisms and cylinders, and we're going to use props to show those things in a little bit. So first question is, what is volume? What's the difference between volume and area? So I'll do a quick side note here. Let's just have a quick area discussion. Okay, so if you had area of something, let's say a rectangle. All right, so we'll say this side is 3, this side is 5, and we'll say it's inches and inches. What would the area of that rectangle be? This should be a very, very easy question. The area of that rectangle would be 15. But if you are in my class, you know that that's not a good enough answer. No label, no credit. So yeah, my area is going to be 15. But 15 what? So here's the big difference between area and volume. Area is a two-dimensional measurement. We're only keeping track of things in 2 dimensions. You have a length and you have a width, or you have a base and a height, whatever you want to call it, but bottom line, there are only 2 dimensions. That's why your answer for the area of this problem is 15 inches squared, or 15 square inches, with the 2 above the inches, because this is in 2 dimensions. All right, so that's what area is. What you're really finding out here is 15 inches squared. So an inch would be that. From here to here is an inch. A square inch is literally a square inch. And so when you're finding the area of the square, I want to know how many of these square inches fit inside this rectangle. And since it was a 3 by 5 rectangle, well, look, there are 15 square inches. And now, by making the shape, you can literally see each and every one of those 15 square inches. So that's what area is. Area is two-dimensional. So I told you this was going to be a video about volume. So what is volume? Well, volume is three-dimensional. So I told you there was going to be props. So here are the props. Here's a three-dimensional figure Legos. Now this, when we're going to find the volume of in a second, you're not going to measure this volume in inches or inches squared. You're going to do it in cubic inches. And what that means is that we're going to measure it in how many of these make up that I just showed you. So we're just going to pretend that this is a perfect cube. Realize that I have a lot of my supplies back in the school building, which I can't get into, so I'm resorting to my son's toys. So we're just going to use Legos for this. But bottom line, volume is measured in 3 dimensions: length, width, and height. There are 3 dimensions now. So when you have a volume problem, your final answer is going to be inches cubed is going to be the label, or cubic inches. Bottom line is, I want to know how many of these it takes to make this. So let's talk about how we're going to find that. So the first thing I have up on this board here is volume of a prism. So let's talk about this word. What is a prism? So before we get into any of the formulas, a prism is any shape that has any 3D shape, it's a closed 3D shape that you have the same shape on the bottom as you do on the top. So this is, I have a square on the bottom and I have a square on the top. I know there's the bumps on the top because this is Legos. Just pretend that it's a perfect rectangular prism, because that's what this would be, a rectangular prism. And again, a prism means that pretty much you had a flat square, you had a 2D square, and it was stretched out to become three-dimensional, but you have that square at both ends. That's what makes it a prism. So a triangular prism would have a triangle on both ends. A rectangular prism has a rectangle on both ends. I could even have a heart-shaped prism that has a heart on both sides, or a star-shaped box that has a star on both sides. Those are all prisms. All prisms have the same shape on both sides. And again, it's just one flat 2D shape, a square that is stretched out to be three-dimensional. That makes a prism. So any prism that we encounter, we know that the volume is going to be the area of the base multiplied by the height. Just fit it in there. All right, so every single prism we encounter, the volume is going to be the area of the base times the height. So this video is going to talk about rectangular prisms and cylinders. Now, technically, there's a technicality that cylinders are not prisms, but they have the same characteristics of prisms, so we can use this area of the base times the height to get our formula for that. It's going to be really, but technically speaking, a cylinder is not a prism, kind of because it has no circle and it was a special kind of shape. We're not going to get super into that. So the first I want to go into, and we'll do an example together, is the volume of a rectangular prism. So now I know that there's people already out there saying you've been doing volume of rectangular prism, have that formula down pat. You know that it's going to be length times width times height. And you know what? You're right. It is going to be length times width times height. But I want you to stop thinking that volume is length times width times height, because like I said, we're going to get into volume of rectangular prisms and cylinders, and later on cones, and later on pyramids, and even spheres. And the whole length times width times height thing, that's only going to work for rectangular prisms. So if we're thinking of it as area of base times height, that's going to help us out when we're trying to use our formulas to help us find volume. Here's what I mean. Let's bring back that rectangular prism from before. All right, so yes, you might be thinking, okay, it's going to be length times width times height. And again, you're not wrong. I'm not saying you're wrong. But I want you to think of it as layered area. That's why I built this. And yes, I built this, and I did a great job. Thank you. But that's why I want you to think of volume as layered area. Volume is literally how many layers of area do you have to make your entire 3D solid. So if I pop off the bottom, my base, all right, here's my bottom base, and how much area does my bottom base have? How many units of measurement? How many things do you see there? You see 4. It's a 2 by 2 square, so there's 4 on the bottom. So now when I put this back on my rectangular prism, this is a volume of 4, this is a volume of 4, this is 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 4. These are all areas of 4, I meant to say. The bottom line is you have that area of 4, how many ever times your height is. Your height is 1, 2, 3, 4, 5, 6, 7, 8. So that means the volume of this rectangular prisms, how many of these it took to make this, is that area, that area of 4 multiplied by 8 layers, because 8 is the height. 4 times 8 is 32. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. I probably didn't need to take the whole thing apart, but I think it helps it, and I think you get the point. So yeah, the volume of a rectangular prism, it is length times width times height, but really what's happening, it's the area of the base. So in this case, it's your area of the rectangle times the height, and that's what the length times the width is. So yeah, length times width times height, it's right, but you guys have been saying that forever that you don't even know what it means. It means the area of the base times the height. So when you have rectangular prisms, it's the area of the rectangle times the height. That's how we find volume of rectangular prisms. All right, so now I told you the next shape we're going to talk about is cylinder. Again, a cylinder is technically not a prism, but I have a cylinder right here. It's one of our sponsors, 4C Panko Breadcrumbs. Not really a sponsor, but free plug to them because it was the first cylinder I found in my house. So, but again, it has the same characteristics of a prism because really a cylinder is just a flat circle that is stretched out to become a three-dimensional prism. But I have a circle on the bottom, I have a circle on the top. They are my bases. The bases are stretched out, and that's how I get the 3D volume of a prism. So, since it is kind of like a prism, that means the area of the base times the height will work again. But now I no longer have the rectangle as my base. My base is now a circle. So that means the volume of a cylinder is going to be the area of a circle times the height. So what is the area of a circle? Hopefully you remember, we talked about it a little bit before we left, but area of a circle, it's not pi times diameter, that's circumference. Area of a circle is pi times radius squared. That's area of a circle. So pi times radius squared is area of a circle. So the volume of a cylinder is going to be pi times radius squared times height. All right? So pi times radius squared times height. That's what that says. I know it's not the best handwriting. I know I kind of ran out of space on my board here, but that is what it says. So those are my big formulas. And I'll demonstrate volume of a cylinder as far as that layered area goes. Here is a hockey puck. It was one of the best hockey games I ever went to. There's the date. Look it up. It was a great night. One of the best nights of my life. But I'm not going to talk about that right now. All right. So right now, here's the circle. So if I take out my tape measure, which I can't find, but I had it. Oh, man. I'm going to ruin the whole video. Well, I can tell you. I already know that the diameter of every single hockey puck is exactly 3 inches. So that means that the radius of this hockey puck, if the diameter is 3, the radius has to be 1.5. So let's do a volume of a cylinder problem together. We're going to find the volume of a cylinder. So volume of a cylinder. All right, and again, our formula, it's the area of a circle. Okay, volume of a cylinder, it's the area of a circle. Sorry, I should have shut my phone off. Times the height. Okay, it's always going to be area of the base times the height. When I have a cylinder, my base happens to be a circle. So in this case, it's going to be pi times radius squared times height. So I already told you that a hockey puck has a radius of 1.5. Pi, we're just going to use 3.14. So it's going to be the area of that circle times the height. So I have a lot of hockey pucks in my house because I go to a lot of different Islander games. Let's go Islanders, missing hockey a lot. So we're going to find the volume of this puck cylinder that I've made by stacking these pucks on top of each other. So again, the volume of the cylinder is going to be the area of one puck times the height. How many pucks I have, and it might be kind of tough to see on the screen, but I have 6 pucks in this cylinder. So it's going to be the area of the circle times 6. 6 is going to be my height. All right, so that's what the volume of the cylinder is going to be, and you are actually going to figure that out. So props to the tops if anyone can find out what the volume is. No label, no credit. Remember I told you that the diameter of a hockey puck is exactly 3 inches. No label, no credit. You tell me what the volume of my hockey puck cylinder is. All right, I hope you enjoyed this video. Oops, phone down. Hope you enjoyed this video. I hope it was helpful. I tried to keep it under 15 minutes, but hopefully this will help you understand your volume formulas moving forward. All right, stay safe, keep watching your hands, and let's go Islanders.